All right, here I am back on my dashboard. We're going to do 8.2 today. So we'll click on Algebra 1, Distance Learning Math. We'll go to Modules, and let's work on 8.2. Now remember, we just did in the last video greatest common factor. It took a long time. I apologize for that, but I did want it to be very, very thorough and as detailed as I possibly could in the shortest amount of time I possibly could. I mean, 50 minutes is one class period, so I mean, you can't really blame. Anyway, we did the notes, and then you guys should have done the quiz. I can't remember if it was 7 questions. I don't remember how many it was. But now we're going to do the factoring by grouping 8.2 notes, and you guys can then do the 8.2 quiz. All right, so let's look at the notes. So remember to click through these. We are going to go through the buttons on the top right here. When I want to hit the next button at the bottom, that's me ready to take the quiz. So we're not going to hit that until we've clicked through all these notes first. So let's get started. Variable town needs your help. There is an infestation of ants, which are in variable town are referred to as A's, and cockroaches, which in variable town are referred to as C's, and they must be exterminated because nobody wants any A's or C's, do they? Right? Read on to find out more details about the problem and the job qualifications required. So coronavirus has attacked this village of insects, okay, or whatever they are, right? Variable town, okay, ants and cockroaches. The town of variables has become infested with A's and C's. The other variables who live in this town are kind, gentle, and most of all, clean, right? Not coronavirus. They're doing the distance learning like you are, social distancing, very good people. These variables are of the B and D varieties. No A and C's are welcome in variable town. A's and C's are despised, detested, and downright disgusting to the other upstanding variables of the town, right? The A's and C's must be quarantined and destroyed. Remember, because of the coronavirus, right? But expert help is needed. And the infestation in one neighborhood looks something like this. AB plus AD plus CB plus CD. Okay, I almost messed that up. The A's and C's are seen all through the variable homes. Do you think you can help? Somebody with knowledge about polynomials, exponents, and how to factor out a GCF is needed. Although an A or C cannot be factored out from all 4 homes terms of this polynomial neighborhood, there is still a way to factor it so the A's and C's are separated, quarantined, from the B's and D's. Further, on-the-job training will be provided. Okay, so essential questions. We're going to answer these essential questions at the end. So the essential questions are, what is the structure of a polynomial expression that can be factored by grouping? And how is the GCF used when factoring by grouping? So we'll be able to know the answers to these questions after we've gone through these notes. So let's get started. Another way to factor. So remember we did GCF before. If you're lost on that and need some help on that, please go review it. If you're not comfortable with GCF yet, you have to go practice that more before you do this section. There's no point in trying to do this section if you can't do GCF. So make sure you're good on GCF. Okay, make sure you've passed the GCF quiz. If you need to, I've made even more GCF videos in the past from teaching my other schools from long ago. So if you want to search my YouTube channel for greatest common factor videos, I'm sure you'll find them. Or just ask me again in the discussions tab over here. Ask me questions. I'll be able to answer them over there. Okay. So, well, hold on to your bug spray because you are about to get GCF crazy, right? Like I said, we have to know that method a lot in the most excellent sort of way. While identifying the GCF of a polynomial, you look in the coefficient for the coefficient GCF and the variable GCF. Once you found those parts of the GCF, you multiplied them to get a monomial GCF one term. This is just basically explaining what we did before with the GCF, right? We factored it out. So we have an example here, right? 7x to the third minus 28x squared plus 3x minus 12. So let's go to my whiteboard and let's work on this problem together, right? 7x to the third let's see, 7x to the third minus 28x squared plus 3x minus 12 plus 3x minus 12. All right, now here's the thing. This polynomial has 4 terms, right? 7x to the third, negative 28x squared, 3x, and negative 12. 4 terms. Now, not all 4 terms have a GCF in common. There's not a single thing that all 4 terms have in common. So there is no overall GCF. There is no GCF for the whole polynomial. Okay. However, this method is called factor by grouping. It's very important, that word grouping. Let's talk about that in a second. Let's click through this real quick. So as we just mentioned, no, the coefficients 7, 28, 3, and 12 do not have a common factor, and neither do the variables because the last term is a constant with no variables. So that's saying that between the coefficients 7, negative 28, 3, and negative 12, there is no number that will divide all 4 of those, right? For example, the only number that will divide 7 is 7 and 1. And 28 can be divided by 7, but 3 can't be divided by 7. 12 can't be divided by 7, right? So there's no number that divides all 4 of those. And if you look at all the terms, the first 3 terms all have an x in common. They all have at least one x, but the last term has no x's in it. So they don't all have x's. You know, remember, you need all 4 terms to have something in common. And if the last term doesn't have an x, then they don't all have an x in common, unfortunately. So that's what they're saying there in the blue. So one may be quick to conclude that the polynomial is prime, not factorable, but that is not the case. It is still factorable. Now, putting our GCF finding skills to work, do we see any GCFs? And the answer is yes. So here's what we do by grouping. We're going to group. You'll see the first 2 terms I can group together, and the last 2 terms I can group together. So now I've made 2 groups, right? I've got this first group, and I've got the second group. Now, in the first group, completely ignoring the second group, in the first group there is a GCF. So between these 2 terms, there is something in common, right? Look at the coefficients, 7 and negative 28. Between 7 and negative 28, both of those numbers can be divided by 7, right? 7 can divide into 7, and 7 can divide into 28 as well. So both of them can be divided by 7. And they also both have x's in common. The first term has 3 x's in it, right? Because it's x to the third. And the second term has 2 x's in it because it's x squared. So in common, they both have at least 2 x's, right? The first term has 3, but the second term has 2. So they don't both have 3 x's, but they both have at least 2 x's. So x squared. So it does have a GCF. It can be divided by 7x squared. So we're going to factor by GCF just those first 2 terms. Remember, we're kind of ignoring the 3x minus 12 right now. So when I factor this out, that 7x squared is going to come out of those parentheses, out of that group. So the 7x squared goes on the outside of this group. And now we divide to see what's left. So if I divide this first one, 7 divided by 7 is 1. And then if you have 3 x's on top and 2 x's on bottom, remember x, 3 x's on top, 2 x's on bottom, then that pair of x's cancels, that pair of x's cancels, and we just have 1 x remaining. So simply just 1 x remains here. Okay, 7 divided by 7 was 1, and then x to the third divided by x squared, you have 1 x left over. So it's simply 1 x to the first power. We can just simply write this as x. The second term, negative 28, keep in mind that negative is still relevant here. Negative 28 divided by 7. Well, 7 goes into 28 4 times. This is going to be negative 4. Now, we have the x squared divided by the x squared. So you have 2 x's on top divided by the 2 x's on bottom. X squared divided by the x squared. 2 x's on top, 2 x's on bottom. You have that pair cancels, and there is simply no more x's left at all. So it's just going to be that minus 4. There is no x next to it because there is no x left over. All those x's canceled out, right? 2 x's on top, 2 x's on bottom. They all cancel each other out, and they're gone. So we have the first group factored, 7x squared, and then in parentheses, x minus 4. We can do the same exact thing to the 3x minus 12. It's just another GCF problem. Essentially, what we have here is just two GCF problems. Basically, that's all it is. So like I said, if you know GCF, then you can do this just fine. So the second group, 3x and negative 12, they both can be divided by 3. They have a GCF. Those two terms together both have a GCF. That doesn't apply to the first group. Remember, we've already factored out that first group. But the second group, 3x minus 12, I can divide both terms by 3. The 3x can be divided by 3. The 12 can be divided by 3. And so they don't both have x's, unfortunately, though, right? The 3x has an x in it, but the 12 doesn't. So there is no x as part of the GCF here. So it's just going to be the 3. So we're going to take this 3, we're going to pull it out. So it's going to join that plus sign in front of it. So that 3 is going to sit outside of this group now, right? We're bringing it out of those parentheses, out of that group. And now we'll simply look at what we get when I divide it, right? 3x divided by 3, that's 3 divided by 3 is going to be 1. And that x is not going to disappear because there is no x that it's dividing with, right? That x is still going to be there unchanged, so it's going to be 1x. Again, we'll just simply write this as simply x. The second part, we have negative 12 divided by 3. No x's, nothing like that, it's just negative 12 divided by 3. 3 goes into 12 4 times. It is a negative 12, so it's going to be a negative 4, so minus 4. Now, here's the best part, and this is going to happen anytime you factor by grouping. The two groups that we've made, guess what? They have something in common. They've created something in common. Both groups have the same parentheses. The first one has x minus 4. The second one also has x minus 4. They both have an x minus 4 in common. So we continue factoring by GCF here. We can actually factor out that x minus 4, right? This group and the second group both have x minus 4. So how this works, it kind of looks funny, but we're going to take the x minus 4 out of both of those groups. We're going to take this x minus 4 and throw it all the way in front of this giant thing, right? So it's basically like a GCF kind of beanstalk, right? It's grown, it's scaled up a notch, right? So the x minus 4 is something that both groups have in common. So that x minus 4 we take out, we put it in front. Remember, it's not going to disappear. It doesn't go away. It just gets moved to the side, separate, just like the other GCFs, just like the 7x squared, just like the 3. Right? So I've taken it out. Now, what happens if that first term doesn't have, or that first group doesn't have the x minus 4 anymore? Remember, you're dividing it out, right? It's dividing, it's taking it away. If that first term doesn't have x minus 4, then it's just going to be 7x squared. If the second group doesn't have x minus 4, if that's gone, if that's taken out of it, then it's just the 3. So if you take that x minus 4 and factor it all the way out, bring it to the front, then what you're going to be left with is the GCF of both terms. You're going to be left with the 7x squared from the first group and the plus 3 of the second group. And this is our final answer, factored by grouping. So we'll definitely do a few more examples so you can get the hang of it, but this is essentially how this is all explained here. So you can see here they've, let me, I guess, no, I won't say that. You guys can see it's highlighted in green, right? The 7x to the third minus 28x squared, the GCF was 7x squared. I explained that, I told you that, we found it, right? The 3x minus 12 has a GCF of 3. So you've got two groups. You got the first two terms as one group, second two terms as a second group, and you find two GCFs, one GCF for each group, right? And now when you factor it out, you see, remember, we factored out, we divided the 7x squared GCF out of the first group, we divided the 3 out of the second group, right? And you see we got the same result from the whiteboard, right? I've written all over it, made it a mess here, but it's still there. The x, you notice the x minus 4, so that's the thing that's very important here. Both of these groups have x minus 4, and they will be the same. They should match. If you're doing these problems in the future and you get to this point where you factored out your GCFs and those two groups in parentheses do not match, then either this can't be factored by grouping or you factored it wrong. And 98% of the time, it's probably because you factored it wrong. A lot of the problems we give you in math are meant to be worked out well. They're not going to try and trick you. So if it's factored by grouping as possible, it's always going to have those matching parentheses. In this case, the x minus 4s. They have the matching parentheses. So you can look at this and you can see that what they're going to do is, here it is, right? They take the x minus, big blue arrow here, they take the x minus 4 from both groups and they factor it out completely. It's taken out and it's put in the front. It doesn't always have to be in the front, but it's where they put it most of the time, right? If they take the x minus 4 out of the two groups, then what's left? Well, 7x squared would be left of the first group, and the 3 would be left of the second group, which is why you see on the left side of the screen the 7x squared plus 3. That's what's left over. Now, if you want to go through the process of checking your answer, you can distribute all this back together and see it give you the same result. Remember, distributing and factoring are just opposites of one another. So if you actually distribute this, and remember, this is our final answer, we're done. But if you want to check your work, you should be able to multiply everything back together and get the result we had at the very beginning, the original problem. So x times 7x squared, right? X times 7x squared, that'd be 7, and then x to the third, because you have an x here multiplied with 2 x's there, it's going to combine, make 3 x's, so x to the third. If you do x times 3, you're going to have 3x, right? So this is just distributing, it's foiling. We've done this maybe once or twice, right? We've done this before. If we factor the 4, negative 4 times 7x squared, negative 4 times 7 is negative 28. X squared is still there. And then negative 4 times 3. Remember, this is not part of the problem. We've already finished the problem. This is just a way of going backwards and checking our answer again. So negative 4 times 3 is negative 12. And there you go. Just like that, you've got the exact same problem we started with. We could just, I think we have to rearrange these two terms, kind of flip them around, but it's still the same thing. 7x to the third minus 28x squared plus 3x minus 12. This is exactly the problem that we started with. And that means we factored it correctly. Because remember, factoring and distributing are opposites of the same thing. So you should be able to see that result. So that's kind of a neat little way of tying it all together. And that's what this last part is saying, that you can multiply them together and get the exact same result we started with before. All right, let's try this example. There is a video here. Video is not great, but I mean, it does work. But we'll try it in my video. 4x to the third minus 2x squared. So let's try this. 4x to the third minus 2x squared. And plus 6x minus 3. Plus 6x minus 3. Now, there is no GCF between all four terms. It's very important that we look for that, though, because sometimes there is, and it's going to help us. But in this case, there isn't a GCF in all four terms, right? Not all terms have an x. And it looks like most of the terms are divisible by 2. Like 4 you can divide by 2, 2 you can divide by 2, 6 you can divide by 2. But the 3 you can't, right? The 3 you can't divide by 2. So there is no GCF between all four terms. So what we're going to do is we factor by grouping. Remember, grouping is a very important word here because you're grouping the first two terms together and the second pair of two terms together. And yes, it typically is always going to be the first two terms and the last two terms. That's how you want to group these. Shouldn't have to do it other ways than that. So yeah, group the first two terms together, group the second two terms together, and I threw parentheses on them as my way of showing that they're grouped together. So now let's do two GCF problems, right? One of the first group, one of the second group. So the first group, what can I divide both of these two terms by? Let's look at the numbers first, right? 4 and 2. What's the biggest number that divides 4 and 2? There's only one number, and that's 2. I can divide both 4 and 2 by 2, right? Now let's look at the x's. We have 4x to the third, which means it has 3 x's, and then we have x to the second, which has 2 x's. So the most that they have in common, the least that they share, is they each have at least 2 x's in common, so x squared, right? First group's got 3, second one's got 2, so they have at least 2. They both have at least 2 x's, right? So x squared. So there you go. There's your GCF, right? We're going to factor this out. The 2x squared is going to come out. And now in parentheses, we got to find out what's left over. So let's divide, right? The first one, 4 divided by 2 is going to be left with 2. And then you have 1x or I'm sorry, you have 3 x's on top, 2 x's on bottom, which means you'll have 1 x left over, right? You have 3 x's on top, 2 x's on bottom, that cancels, and you have 1 x left over. It's simply kind of just subtraction. Hopefully you've kind of seen that by now. Subtracting the x's. You have 3 on top, 2 on bottom, so you take away those 2, you're going to have 1 left. So x to the first. 4 divided by 2 is 2, and then we have just x to the first, or a regular x, just a single x, not x to the second, not x to the third, just an x. Second group, or second term, we have negative 2x divided by 2. Now this is very important. It's negative 2 divided by 2, still a negative 1. But we have 2 x's on top, 2 x's on bottom, and those will all cancel out. X squared divided by x squared. 2x on top, 2x on bottom, they both cancel out. There is no x left over. It's just going to be simply minus 1. Okay. A lot of times people think it turns into 0. They think that 2 divided by 2 is 0. And the x squareds cancel out. There's 0 x's. So a lot of times people like to think that that number is 0, but it's not. Be very mindful that negative 2 divided by 2 is still 1, right? Negative 1. So be mindful of that, okay? So there you go. You've got the first group factored by GCF. The second group, what do 6x and 3 have in common that we can divide by? Both terms can be divided by 3. And that's it. They don't both have x's, right? It's just 3. We can divide both terms by 3. So we factor this 3 out. We bring that 3 in front of the parentheses. And now we divide, see what's left over. So 6x divided by 3. 6 divided by 3 is going to become 2. And remember that x didn't go anywhere, so that's x is still there. Now here, negative 3 divided by 3, remember, is negative 1. A lot of times people think it's 0. That's a big mistake. It's a big no-no, okay? Don't do that. When you're doing division, you're really never going to get 0 as the answer when you divide, okay? Unless the top part already was 0, but we won't see that. Okay, so we have 3 goes into 3 once, right? That's why it's negative 1 there. So you'll notice at this point, you should see, I've mentioned this earlier in the video, you should see a common factor. You should see the parentheses in common. And both of these groups that I've done, both came to 2x minus 1 in parentheses. So let's just make this a shortcut. Let's jump to the conclusion. Let's skip all the confusing math stuff. Let's just answer it, right? The final answer here is 2x minus 1. Oops, that looks like a plus sign. 2x minus 1, and then 2x squared plus 3.